What really makes the human mind, well, us, so unique? And the big question, can artificial intelligence ever genuinely mimic that incredible complexity?
That's the million-dollar question, isn't it?
It really is. Welcome, everyone, to the Deep Dive. We love unpacking the frontiers of AI research, and today we're diving into something pretty fundamental.
Hmm.
It's a core concept that's quietly, reshaping how we think about AI. It's often called the consciousness loop.
Sounds intriguing.
Yeah. Our mission today is give you a kind of shortcut to understanding how AI is shifting gear, moving beyond simple linear processing.
Like a calculator.
Exactly. Moving towards mirroring the dynamic, the continuous feedback loops we actually find inside our own brains. So get ready. We'll explore some direct, maybe surprising parallels between brain architecture and, well, cutting-edge AI.
Looking forward to it.
Okay, so let's unpack this consciousness loop. It
Hmm.
sounds pretty profound, right? But at its core, you're saying it's not really a static thing.
No, not at all. That's key. It's an active process. Continue.
Right, a process. Why is defining it that way so fundamental?
Well, it's because the consciousness loop isn't describing an object. It's describing a mechanism, a fundamental feedback mechanism that's always in motion.
Okay.
So imagine any complex system, could be a brain, could be an advanced AI. It starts by taking in sensory data. That's its input.
Right, the senses.
Then it processes that data, uses it to build, or rather construct, an internal model of the world around it.
An internal picture.
Sort of. And based on that model, which is always evolving, by the way, it decides to act on the world. That generates an output.
Like input, processing, output. Seems standard so far.
But here's the crucial part. The loop. It immediately observes the results of its own actions. This is the feedback.
I see, so it watches what it did.
Precisely. And then this is the clincher. It uses that feedback to continuously update its internal model.
The picture changes based on the results.
Exactly. And that updated model informs its next action. So you have this constant iterative cycle: predict, act, observe, update.
Predict, act, observe, update.
That's the core of this fundamental loop. It's never static. It's always cycling.
So if our brains are wired with these continuous feedback loops, it really changes the way we think about simple input-output, doesn't it?
It absolutely does.
It makes you wonder just how much more dynamic these systems, our brains, truly are. And this human architecture, as you call it, that's clearly what AI researchers are now drawing parallels from.
Indeed. Yeah, if we connect this to the bigger picture, the human brain offers these incredible blueprints for advanced AI.
Like actual brain structure.
Exactly. Take the thalamocortical loop, sometimes called the loop of awareness.
Okay.
So the thalamus is the structure deep in the brain, often seen as the brain's central relay station.
The hub.
Right, the hub. It relays sensory data up to the cortex for, higher level thought. And this is key, it's not just a one-way street.
Nah.
The cortex processes that information and then sends crucial feedback back down to the thalamus,
Telling it what?
essentially telling it what to focus on next, what to prioritize. This constant back and forth, well, it's actually considered a physical basis for our moment-to-moment awareness.
Wow. So if the brain has this incredible filtering, this prioritizing system, how does AI even start to mimic that kind of focused awareness? Does it just process everything equally, or?
That's where it gets really interesting. It connects directly to attention mechanisms.
Like in GPT and those transformer models.
Exactly. The very models like GPT. Before attention mechanisms, AI models pretty much treated every piece of input data equally. Imagine just a flat, uniform view of everything coming in.
Not very efficient.
Not at all. But now, with attention, the model itself decides which parts of its input are most important for whatever task it's doing.
It weighs them.
Precisely. It assigns them more weight, effectively focusing its internal resources. It's not just about being faster, it's how AI starts to prioritize information, almost like deciding what's important enough to enter its immediate sort of thought process.
Like that thalamocortical loop deciding what's worth paying attention to.
You got it. It's a huge step beyond just crunching all the data equally. It implies, maybe, a nascent form of internal discernment.
Okay, fascinating. What other loops are there?
Well, then we have the basal ganglia loops. We could call this the loop of action.
Action. Okay.
This system, also deep within the brain, is vital for deciding which action to take from, well, tons of possibilities. It's often described as a kind of go-no-go circuit.
Go, no go. Makes sense for action.
Right. It takes goals from the cortex, selects a motor plan, executes it, and then crucially gets feedback on the outcome.
The feedback again.
Always the feedback. This is how we refine movements, how we form habits, how we make sequential decisions.
It sounds like an incredibly practical system for learning. So when you say it's a direct copy in AI,
Hmm.
are we really talking about an AI learning through trial and error, getting better?
Absolutely. You're describing reinforcement learning, or RL, perfectly.
Okay, RL. Heard a lot about that.
In RL, you have an AI agent operating within an environment. It takes an action. The environment then gives back a reward or a penalty that's the vital feedback.
Reward or penalty? Like points in a game.
Exactly like points in a game. Think of an AI learning to play Pac-Man. It tries moving up, maybe it gets eaten, penalty. Tries eating a dot, reward. It then updates its strategy to maximize those future rewards, those points.
So it learns by doing.
Precisely.
Hmm.
It mirrors how the basal ganglia refines our decisions and builds habits through consequence.
Amazing. Okay, awareness, action. What else?
Next up, let's consider the hippocampal loops. We can call this the loop of memory and reflection.
Memory and reflection, that sounds deep.
It really is. The hippocampus, it's this fascinating region sort of nestled deep in the temporal lobe. It's incredible. It takes our current experiences and essentially replays them to the cortex.
Replays them. When?
Especially during sleep, interestingly enough.
Ah.
This process helps consolidate short-term memories into long-term knowledge.
Turning today's events into lasting memories.
Right, and it allows us to learn from the past, even simulate future possibilities. It's how we build narratives, make sense of our experiences over time.
So this really sophisticated memory process, this replaying and consolidating, how is that being modeled in AI? It sounds like AI would also need a way to kind of ruminate on its experiences, maybe.
That's a perfect way to put it, ruminate. This parallels things like recurrent neural networks or RNNs and other advanced memory systems in AI.
RNNs.
Yeah.
Right.
Unlike older sort of linear AI, RNNs have this built-in loop. It feeds information from one step back into the next step.
Giving it memory of what just happened.
Exactly, a form of short-term memory. This is absolutely essential for processing sequences like language, where the previous word matters, or video, where the last frame matters.
Context.
Context is king. They carry that context over time, much like the hippocampus consolidates and replays information. It allows the AI to remember previous interactions or data points within a sequence.
Okay, so we have loops for awareness, action, memory. Is there something that ties them all together?
That brings us neatly to global workspace theory. This is a really powerful cognitive theory. It tries to unite all these individual loops into a coherent picture of consciousness.
Consciousness itself.
Okay, it suggests consciousness is maybe like a spotlight on a theater stage.
A spotlight.
Yeah, and you have all these unconscious processors. Think of them as different experts, like for vision, language, logic, sitting in the audience, kind of in the dark.
Okay.
These experts compete to broadcast their most important information to the bright global workspace, which is the stage itself under the spotlight.
So the important stuff gets on stage.
Right. And once that information is on stage, it's then broadcast back out to all the unconscious processors, all the experts in the audience.
Treating like...
An integrated, unified state of awareness. Everyone gets the memo, basically.
That's a powerful image, a dynamic stage where different experts contribute and receive information. So what does this all mean for how AI is actually built? It sounds like we're moving from just building clever individual algorithms to crafting entire interconnected architectures, ones that mimic this integrated brain activity.
Precisely. You've hit the nail on the head. We are seeing a really fundamental shift in AI architecture.
From what to what?
Well, historically, what we might call old AI often used feed-forward networks. Information just flowed in one direction. Input hidden layers, output.
One-way street, no memory of past steps.
Exactly. But looped AI, the kind we're talking about, embraces things like recurrent neural networks, RNNs. As we just discussed, they have that built-in loop, feeding information from one step back into the next.
Giving it that short-term memory, crucial for sequences.
Essential. It mimics a basic processing loop.
Okay. And you mentioned reinforcement learning again.
Yes. Reinforcement learning is another core example we touched on. It's probably the most direct implementation of that action feedback loop.
Agent, environment, reward, penalty.
That's the cycle. Agent acts, environment gives feedback, reward or penalty, agent updates strategy. This continuous cycle is how AI agents learn incredibly complex behaviors, from playing Go to controlling robotic arms.
And learning by consequence.
And then there are the attention mechanisms. These are arguably the revolution behind models like GPT.
Right, you said they help focus.
Exactly. Before attention, AI treated all input equally, this flat, undifferentiated view. But with attention, the mechanism itself is a kind of loop within the processing.
How so?
The model actively looks at all its input data, then decides which parts are most relevant or important for the current task, and gives those parts more weight.
Like the thalamocortical loop again.
It's very analogous. It's performing an internal thalamocortical loop, focusing its own computational resources based on context. This allows for much richer, more nuanced understanding of complex information, like long texts or intricate images.
So RNNs for memory, RL for action, attention for awareness. What's next? What's the future look like?
Well, looking ahead, the sort of next frontier many researchers are excited about is global workspace architectures for AI.
Bringing that theater stage idea into actual AI design.
That's the vision, building AI systems with specialized expert modules, like different brain regions for vision, language, logic.
Okay.
These experts would all be connected to a central global workspace bus, like the stage.
The communication hub.
Right. And the experts would, in a sense, compete to broadcast their most critical findings to the central workspace.
The important stuff gets through.
And then that information gets broadcast back to all the experts. This creates potentially a unified, maybe even conscious-like state
Whoa.
that guides the AI's overall behavior.
Yeah.
It's about bringing all those different loops together, memory, action, attention, to form a more integrated adaptive intelligence.
Okay, so to sort of wrap this up, the core insight here seems to be that to create truly more advanced AI, we are fundamentally moving away from seeing them as just linear calculators. Instead, we're building systems that try to mimic the brain's dynamic architecture by integrating these powerful feedback loops.
That's the essence of it. And this shift, it enables AI to achieve, I think, 3 critical abilities that bring it closer to how we understand biological intelligence.
Okay, what are the 3?
First, to reflect, meaning to assess its own processing, primarily through things like attention mechanisms.
Got it. Reflect.
Second, to act and learn, interacting with an environment and continuously learning from the consequences of its actions thanks to reinforcement learning.
Act and learn.
And third, to remember, carrying context over time, which we see in recurrent networks and other memory systems.
Reflect, act and learn, and remember.
Those 3 pillars, enabled by these loops.
So by combining these different types of loops, we're building AIs that are less like static programs, more like, well, the dynamic, adaptive, continuously processing system that is the human mind.
It certainly seems to be moving in that direction.
Which raises a really important question for you, the listener, to consider. As these sophisticated looped systems continue to evolve, become even more integrated, what are the implications for our understanding of intelligence itself?
Yeah, what does intelligence even mean when a machine can reflect, act, learn, and remember in these increasingly complex ways? It's something to think about.
Definitely something to ponder. We encourage you to maybe observe the AI technologies around you, your phone, recommendation algorithms, and see if you can spot hints of these loop concepts in action.
And please, continue your own deep dive into the fascinating future of AI. There's always more to learn.